All right, welcome back, everybody. Thrilled to kick off the afternoon's activities with a wonderful panel. It's going to be moderated by Kirk Jordan. Kirk is a distinguished engineer at IBM and an applied mathematician by training, PhD in applied math from University of Delaware, if I'm not mistaken.
That's right.
So a perfect panelist for our convening today. Let's welcome our speakers.
So I'm here to moderate, so I get to ask all the questions because you're not going to get to ask the questions. But I'm here to introduce our speakers. So we're going to start with Marcos Krishnikov, okay. And that's not even close. Miriam Kirin from Oak Ridge. Oh, and Marcos is from Phasecraft. And then we have Rosalind Shadulin, okay, from JP Morgan Chase that you heard this morning. So what I asked each of them, they got to see some of the questions that I may ask. I didn't promise that they would all be on the list that I gave them, but I did ask them to give, each of them to give an overview of their organization and their mathematical or science background, so everybody gets to know them a little bit. Because coming from industry, I know a lot of academics would like to understand how they might move back and forth. And then I asked them, what is your organization's interest in quantum? Because it may not be entirely obvious, although I think, people will understand that. And then what is their particular role in the organization to bring about the quantum revolution? All right, so we're going to start at that end because you spoke last, so you're going to speak first.
So the question is about the
just give an overview, just a brief introduction about yourself and the company and how you might work with others within that company.
Sounds good. So at JP Morgan Chase, I'm part of the Global Technology Applied Research Center led by Marco Pistoia. The Global Technology Applied Research Division, not center, is really focused on many areas. There's a teams focused on computer vision, AR, VR, Internet of Things, and so forth. And one of the teams is a quantum computing team, and that's the team that I'm on. I also want to highlight JP Morgan Chase has a significant commitment to quantum key distribution. They have a lab in Singapore. There's more coming out of that. They recently had a demonstration connecting two data centers in Singapore with quantum key distribution at production throughput. So there's a lot of interest in quantum technologies broadly at JP Morgan Chase. I am on the quantum computing team, which has three parts. The way we like to talk about our mission externally is our mission is on one hand near-term value. So there's a team works in quantum-inspired algorithms, or really randomized algorithms, which have now been rebranded as quantum-inspired. And those you can run them today on GPUs and you can see production impact. And that's one part of the team, and that's a significant part of the team. And this other part of the team focuses on what we like to call de-risking the future. That is making sure that we're ready to take advantage of the early fault-tolerant quantum computers when they come. And so the regime we're trying to target is hundreds of qubits and billions of gates. Hundreds of qubits and billions of gates. And for this, there's two parts of the team working on this. There's the theory team, led by Shamanik Chakrabarty, which focuses on, devising novel quantum algorithms. Some of the work I had on the slide today, including all these new algorithms with supercratic speed-ups over Markov chain search, quantum algorithms for branch and bound, that's products of the theory team. And the second part of the team that I'm a part of focuses on bridging the gap between the algorithms, theoretical algorithms, and being able to run them on quantum computers. We call it implementation execution. And it focuses, on circuits, error correction. Michael talked about it yesterday, and anything in between. So that's my area of focus.
Okay, Miriam is from Oak Ridge. Oak Ridge is not really a company, but as SIAM kind of clusters things together, industry and national labs kind of fall together. So Miriam represents the national laboratories here. And if she could just tell us a little bit about her organization and how she fits in. So Miriam?
Sure. So Oak Ridge National Lab, as Kirk described, so it's part of the DOE National Lab System. So the Department of Energy has a number of national labs across the US. So at Oak Ridge, I'm part of the Quantum Information Science section, where we have three groups. One is quantum sensing, the second one is quantum computing and algorithms, and the third one is quantum networking and communications, where I'm the group leader of. My own background is coming from classical computer science, so I did my PhD in AI, HPC, those kind of systems, and I developed my career through the DOE system, building AI solutions to make networks smart and self-driving. And although I've been working in wide area and wireless networks, I got interested in how quantum networks could also use AI to become more intelligent, so that kind of brought me to Oak Ridge. So the DOE has interest in developing quantum because we see it's a science challenge for us. We see a lot of detectors are going to be having quantum capabilities in them. We have some use cases like the high energy physics has the dark matter detection, the gravitational wave detection problem that we want to do, and you can only do it with quantum sensors that are distributed across the globe, and you network them together. So we have some very concrete DOE applications that we want to achieve. So from a science perspective, we want to push quantum computing and quantum networking to the next phase where people can start using that. My work in all of this, so I'm a computer scientist who's working with physicists, which is a very interesting job. Half the time they don't understand me, I don't understand them. So I'm looking at all the physics experiments which they've developed and see how it can be scaled up into a quantum network, or possibly the quantum internet. So where everything is at level 0 and 1 on the tabletop, how can we take it to how optic networks or how our internet exists right now? So that is my own research in this area.
Okay, and Marcus from Phasecraft, so tell us a little bit about what you're doing and what Phasecraft does. It's, as I learned about this, it's a company that emanated from the UK, where I was the chief science officer for IBM Research in the UK, so that caught my interest, but he's here in the US, and maybe you might explain a little bit of that.
Sure, happy to tell you about Phasecraft. Just a quick disclaimer, whatever I say are my own opinions, but I'm happy to tell you about Phasecraft and the work that we do. So Phasecraft was founded in 2019 in the UK by Bristol and University College London professors in quantum computing. And the company has grown since, and in the last 4 months we opened new offices in the US, based here in Washington, DC. And our focus is on the goal of achieving what we'd like to call scientific quantum advantage. So that is a goal which is of interest in itself. By this we mean achieve a new scientific discovery in the realm of quantum mechanics, which is allowed by quantum computers. This is a lofty goal in itself, but we also think it's a necessary goal towards the more long-term goal of industrial or commercial quantum advantage. My personal background is in theoretical high-energy physics. I did my PhD in string theory, and I switched to quantum computing about 3 years ago. I got interested, I got very excited about what was going on in the field with these quantum supremacy experiments and a lot of theoretical developments. The company, we have a number of other physicists with backgrounds in material science, many body physics. There's some chemists, there are a few mathematicians, applied mathematicians, computer scientists, of course. And my role is to identify problems of significant scientific interest where we think we can make significant progress towards quantum advantage in the near term.
Great, thank you. So with that introduction, we'll get into some of the questions that I dreamed up. So everyone can blame me for, the questions that I am about to hit on here. So one of the questions that SIAM kind of asked a little bit about this, and it's kind of over there on workforce area, is all of you are working not in academic institutions. So given that quantum is kind of in its infancy, there are very few individuals that are trained as quantum people in the universities today. And so one of the problems that many industries face is where do you get the quantum expertise? What is the background or training you would recommend people get that you might end up hiring, and not necessarily that they be in quantum, okay, but what other areas would you recommend? You know, I mean, everybody here mentioned that they're not a quantum, they weren't trained as a quantum expert in the beginning. So let's start with you, Marcus.
Sorry, so which areas of,
What would you recommend that people be trained in if you were to want to hire a person? What would you be looking for in their backgrounds?
so the nature of the field is very interdisciplinary. So there's not one single thing that, you know, if you're trained in that single thing, well, it's, you know, it's a necessary, neither sufficient requirement to be, to enter the industry. Like I just said, in the company we have physicists, mathematicians, and computer scientists, and each one of those coming from their own backgrounds will have different challenges to learn different aspects of quantum computing. In my personal case, coming from a background in high energy theory physics, I knew my physics and a little bit of math or applied math, but it was difficult for me to think as a computer scientist. So for me, the challenge was to think as a computer scientist, understand how algorithms work, what are the basics of algorithms, what is an algorithmic way of thinking. For me personally, learning a little bit about complexity theory to understand the difficulty of different problems was also important. And I think depending on where you're coming from, learning different things may be more necessary. So if you come from a background in pure computer science, you will certainly benefit from learning some quantum mechanics. And one comment I can make maybe is that there is a tendency sometimes to teach quantum mechanics in this new quantum information manner in which a lot of the physics is taken out from quantum mechanics. And that kind of lowers the entry barrier to people with a background in mathematics or computer science. But that is not necessarily a good thing. So there's a lot of physics in quantum mechanics that is useful to know when you are developing quantum algorithms. And so I would say for a challenge for people coming from that area will be to learn more quantum mechanics, as it was for me to learn algorithms.
Okay, Rosalind, given that you're at JP Morgan Chase, would someone that you might want to hire need some financial background, or would it be kind of what Marcos was saying?
We don't have any financial background requirements. We try to make it very clear in our job posting that you actually don't need to know any finance. You'll learn the finance on the job. But maybe to add a little bit to that, there's a lot of, I think, talk about like how hard it is to find quantum talent. But in my personal experience hiring people, we had the amazing privilege of being able to ask, for people to have publication history in quantum computing. That's the main thing that we evaluate candidates for research jobs on. And there's a number of labs which produce excellent students with excellent publication history already and things very well aligned with our mission in quantum algorithms. So there's a lot of great candidates there coming from those awesome labs. And UMD, Duke, many schools with big quantum research centers, which have been very helpful.
Miriam is working in the area of quantum networks. How do you see that? What kind of background would you need to get into that at Oak Ridge?
So before they hired me, they had experimental physicists working in the labs because they're actually working on developing the lasers and how the qubits work across. And I was the computer scientist who was hired in this. So I actually was that odd one out with a different kind of background. So, but I do see that in order for quantum computing or quantum networking to really scale up to the vision we have in the next 10 years, this is a multidisciplinary problem which will involve mathematics, physics, computer scientists, and physicists all to work together. Some of the things we also look at, like when we're hiring for postdocs, we're looking at publication records, but The labs also offer internships where you can go and do 3 months at certain labs. And we have our own equipment where we bring students in and we put them on small projects where they develop certain experiments. So that is a good thing to have on your CV because it shows that you have some experience and some kind of training working with these kind of devices. But yeah, I think this is a ripe field now where all people coming from all kinds of backgrounds can actually contribute to this big field of quantum. And it's always, you should always think of, you're always unique in your own skills, and what are you bringing to the table? And you could be coming to a completely different group who have no similarities with you, but you are bringing your experience to this. So I brought in software, or how do we automate things, or how do we orchestrate things? Which the current group didn't. So you can always bring your own skills, and that's the attitude people should have when they're joining.
Maybe since there's students in the audience, I can say a few words about, we have many open positions in our team, so maybe I can say a few words about that. We have 2025 summer internships open for people who are interested in quantum algorithms. Please consider encouraging your students to apply. They have just opened. We're doing the first rounds. Apply early. We do fill up by end of fall, typically. And we have many open full-time positions, both on quantum algorithms research, so that I pointed out the main criterion is publication history, as well in the software. So both high-performance computing software for enabling quantum computing research and quantum software to maintain the stack and to support the mission of running things on all fault-tolerant quantum computers. So those do not necessarily require a PhD and do not necessarily require publication history, but require some knowledge of quantum and expertise in software engineering or expertise in running things on supercomputers for HPC.
So that actually brings us to my next question, which most of what I've seen today is sort of a combination of quantum and classical computing kind of working together, all right, in this hybrid kind of fashion. And we'll start with Miriam first. Do you see this as continuing, or is this sort of a short-term thing, and that down the road would quantum computing basically take over certain problems, and high-performance computing or hybrid computing, cloud computing, whatever you want it, would be completely separated from that? So, Miriam, you could start with that.
Sure. So I don't think that we're going to replace our classical computers or classical networks ever. I think quantum will come and work alongside with them as it is starting to progress, because think about the amount of money that has been invested in classical computing and networking over the last 30, 40 years. No, we are not going to replace all of that, right? And as there was a talk in the morning that in certain problems, classical computing is actually a better way of going and solving certain things. So why do you want to complicate your life with introducing quantum computers? So there will be applications that will be more suited to quantum computing and quantum networking. And that is where we see that they will come in and work with the classical stuff. So I see a future which is going to be hybrid more and more cloud type of applications, especially with the startups fueling this also.
All right. Would you like to take a shot at this one, or?
Yeah. I think it's challenging to think of hybrid algorithms. We had these 2 days of talks. I don't know if many hybrid algorithms that combine classical and quantum computation in some non-trivial way really came up. Putting aside variation algorithms and their, of course, mixed long-term prospects, it maybe is an open question of how to combine classical and quantum compute meaningfully.
Marcus, any thoughts from your experience at Phasecraft?
Yeah, I agree with what was just said by both panelists. I believe there's always going to be, quantum computing is always going to be hybrid with classical, in the sense, for the very basic reason that we live in the classical world, and so the input and the output will always be classical. So for that reason alone, it's always going to be, in some sense, hybrid. In terms of combining what's going on in the intermediate process after the input and before the output, it is true, like Ruslan just said, that combining classical and quantum algorithms is hard. On the other hand, like Miriam just said, because quantum algorithms are, we believe, very targeted to solving very specific kinds of problems, it makes sense to leverage classical algorithms as much as you can until you run out of steam. And then at that point, the final part, use a quantum algorithm to bring you across a line for quantum advantage. So if you're trying to achieve quantum advantage from scratch using a quantum computer all the way from the beginning, you're kind of hampering yourself by not using classical methods that are incredibly powerful. So in that sense, I believe the hybrid approach is the right one.
Okay. So here's a little bit more controversial question, maybe. All right. Current AI and social media companies are typically driven by models for increasing profit and wealth for themselves, but the consumer of those companies is an end user, and protecting user privacy has been kind of not what they've been concerned about in their profit model. And so this is detrimental to the user. Now, quantum information science, quantum computing, could this suffer a similar fate, particularly when we've got Rosalind down there with JP Morgan Chase talking about my EFTs, and since what we didn't mention is I have retired from IBM, so I'm emeritus at IBM, but now I am on a pension and investing heavily in these things. So I want to know personally, what your thoughts are on that, Rosalind. And he's going to avoid me.
What are my thoughts on quantum algorithms for ETFs and
How do you
impact your
protect
portfolio
my-
going forward?
Yeah, how do you protect my portfolio? That's what I want to know.
Invest in quantum companies.
But I'm not sure. So I guess one question I could counterpose is I'm not sure how much of it is quantum specific regulation, right? So we have fiduciary obligation to our customers, right? And it's not specific to any particular way you solve a problem, right? Your obligation is to provide the best service in the interest of the customer. And then you can do it with AI, you can do it with quantum, whatever. But unlike something like a social media company, a bank is actually regulated and has certain obligations to you as a user, the way like Facebook does not have this legal obligation. So I think it's quite different. We're already a very heavily regulated industry, and I think there's a lot of protections in place. Maybe there could be more. I'm not an expert on regulation, but I don't know if the same scandals that happened to Facebook have happened to like JP Morgan Chase or other big banks.
Yep.
I don't think we lost customer data, for example, right? We would be out of business if that happened, or abused it in the same way.
I guess my follow-up question to that is, and maybe we can hit Marcos up on this one, is in working at, Phasecraft, is there a way to protect the user from unexpected or unanticipated consequences of using quantum?
I don't really know how to answer this.
That's all right. It may be too early.
Yes, I agree with Ruslan. I think these are all important questions, but I don't see how quantum specifically introduces new challenges. I think it's a general challenge that people have idea how to address, but quantum, I don't see anything specific about quantum that makes the problem harder or easier.
So going to Miriam, because she's the networking quantum networking person, does quantum networking ensure my privacy?
So QKD, or quantum key distribution, is one of the primary use cases of quantum networks. And the argument in research is that QKD is more secure than our current classical, can be more secure than our current classical because of the fact that if somebody tries to eavesdrop between Alice and Bob, you can make out that somebody's eavesdropped and your information has been compromised. So QKD is something which banks are interested in, and that's why they're heavily investing in this, and governments are also interested in this. In Europe, they have a number of projects deploying QKD networks so that they could exchange identity data of patients and with government. there is a lack of QKD investments in the US because of a certain report that came out last year that said that we don't want to invest in QKD. But I see that they will eventually, because QKD is going to be a very powerful thing and that's the main argument for quantum networks. In terms of your argument about AI, so I think the same problems would exist because even if you do quantum machine learning, you would still take the data and do machine learning on it. So the problems that you have in AI would also exist with quantum machine learning. But if you think of quantum networks securing this thing, there is an argument that QKD would be a best way to secure it.
All right. So another SIAM-oriented question is, what would you suggest the most impactful ways for the SIAM community to contribute to the acceleration of quantum information science? And Marcos, we'll start with you because you were thinking there as I was saying that.
Well, one area of opportunity that I see for an organization like SIAM is to take a leading role in educating people and guiding people towards good sources of information. I think that is not trivial. When you just enter the field, it is difficult to identify who are the serious players, which are the claims that are reasonable, which are the claims that are overblown. And an organization like SIAM can play a fundamental role in giving this guidance and kind of a trusted voice in the field. And second, training, events like this and training, organizing courses that will bring people, interdisciplinary people to learn about quantum computing could be another important role.
Okay. What do you think on that, Miriam?
Similar to what Marcus was saying. So training, having workshops like these is really good because there were a lot of questions that I didn't know until I saw these amazing speakers do their talks, and it made me learn a few things. So having these kind of talks and training sessions is good. There's a lot you can do in simulated software. So you could design quantum algorithms and simulate them. There's a number of simulation toolkits out there where you can start learning about quantum stuff. So I think having that kind of training would be beneficial to help us understand some of the terminologies.
Rosalind, what do you think on that? How can the SIAM community help you make more money?
Well, I think one thing that SIAM is very good at is bringing people together across different organizations. So I'm personally an alumnus of the SIAM Broader Engagement Program, which I went to a long time ago as a grad student. It was at SIAM CSE. And I personally found it was very, very impactful for me. I met a lot of people. I ended up after grad school at the National Lab at Argonne. And I don't know if I would be there if I wasn't part of that program. So I think these programs are incredible, and the fact that SIAM supports them, bringing those students, and not just bringing them to a conference, but also like making sure that they're engaged, they're meeting people, they organize these like mentor roundtables. And I think when I did it, like every day there would be a lunch and you would meet a new cool person. I think these are awesome, and they're not that common. I don't know if many other societies do it. So I think that's a great opportunity for SIAM to do more, connecting, maybe making something that's specific to quantum. I think that's a great opportunity.
All right, so another question that I have kind of stems from my own personal experience, but is quantum an area that really needs sort of the government, academic community, and industry to work together? And we'll start with Miriam, because she represents the National Labs, which is kind of a government-owned entity. So she has sort of the government flavor here, and then we'll branch out.
So the question is whether
Government, industry, and academia partnering together.
So yes, so I think, so we already do that. A lot of our projects have academic partners in it, and sometimes, so we don't, we do a lot of experimental work, and we don't develop a lot of the hardware ourselves, so we buy it from industry. And half the time, the devices don't work. So then the industry folks like partner with us and they come into our labs for the first 6 months and trying to get their things work and eventually improve their hardware through that. So we're already doing that, having a very productive relationship across the 3 entities. We also have like patent regulation, so we do go through lawyers before we start this work because any patent developed through this work should be predefined, like who owns it. So that's something which we have a normal practice that we go through when we start a project. So, but definitely more the skills, the better the work coming out.
Right, what about in the banking industry?
Well, actually, a lot of work we do is collaboration with academia and government. So one paper, there was a paper, I think, on James's slide that actually is a joint work with us on random circuit sampling with Quantinuum device. So there, the collaboration is, well, they have the device at Quantinuum, but when you do the random circuit sampling, you want to compute the XCB score, actually understand how well you did on your task. And that requires supercomputing resources. So in that work, this was done on NERSC supercomputer at LBNL. So that's where some of the data points in the validation plot of that paper come from. And that's one example, these supercomputing resources, they're not so easy to get on the cloud. You can't just on demand get 1,000 GPUs, right? You have to like arrange it, it's very difficult. But if you work with government partners, you're able to do it. We work with academic partners. I think a lot of our papers have co-authors from universities just because there's a unique expertise at those places. So I think there's a lot of opportunities and we have to do it. Another thing worth saying is, why do we need industry? Well, I think there's sort of some line of thinking among some people in industry that you just let academia solve your problems, and then once they've solved them, you just go in and cash in and sort of everything's hunky-dory. But I think that's to some extent fictional because the kind of things that maybe you're more incentivized to think about as an academic, there's a gap left between that and what is actually needed to do it in production. Like I talked a little bit about my team's focus on implementation, execution, and bridging that gap. And I think that gap, it's very hard to bridge in an academic environment because you need more resources. And to some extent, it's less rewarded with, you're not going to get a QIP talk out of doing it typically. Though some people have succeeded in that, which is remarkable. So that's the role that industry can play.
Any thoughts from Phasecraft on this?
Well, in terms of the role of the government, I think there are 2 aspects that are worth discussing that are somehow distinct. One of them is because the technology is really nascent technology, the government has a fundamental role to play in the development of this technology because it's the only entity that has capacity to invest over the long term. It is still to be seen if the investment that comes from industry is going to pay off within the time frame that many investors would expect. And in that sense, I think having a strong presence of the government is essential. On the other hand, the second important issue is that the government can also can interfere destructively if the government doesn't understand how far ahead the technology has been developed. And I'm thinking about the government imposing export controls or limitations on visas for foreign nationals to come and be trained in the United States. Seems like a very premature set of policies to take, and that can be very detrimental to a field which is still very nascent. So I think these are 2 important things that should be discussed. In terms of academia, I guess the same applies. Because it's a very nascent technology, academia needs support from government grants, NSF, et cetera, to be able to continue pushing this technology and exploring other alternative hardwares, for example, that perhaps are not the ones that are being commercially pushed by companies alone.
Okay, so I have a follow-on question to that. Should governments, particularly maybe less with JP Morgan Chase, but maybe more with Phasecraft, should there be a mechanism for government funding to actually assist in a way, maybe through the labs, having had some experience with trying to build a private-public partnership with the labs? It's not easy. But should government, the US government or other governments, get involved in trying to support funding that might, help both academia and startup companies, and actually filter a little bit into the more established companies? Should government funding maybe be targeted at that, or should they just stay away? And given that this is almost an impossible task to do for other reasons, but it's worth trying if you see that. So maybe we'll start with the big company at the end of the row there and see, do you see any value in government helping you guys out?
So government does help us a lot. So the use of user facilities has been, very crucial to our work. I had on my slide some evidence that QAOA offers a speed up, which is one of the first evidence that QAOA offers speed up. But where does that number come from? Well, we built this custom high-performance simulator for QAOA, and we ran it on Polaris supercomputer at Argonne with up to 40 qubits, using up to one of the data points that on the paper is 1,000 GPUs running, for maybe half an hour. So it's not, you can't really do it on the cloud. It's very difficult to do on the cloud because you don't need to just have many GPUs. You need them to be connected by high-performance interconnects, because you have this all-to-all, MPI all-to-all communication is one of the steps of the simulation. And so for this, you really benefit heavily from being able to work with somebody at a user facility. In that case, we worked with Yuri Alexeyev and Jeffrey Larson at Argonne National Lab to get to run it there and to optimize the code. So that's one way. It's not literally giving money, but it's having access to user facilities.
So I'll go next. So yeah, so I think the government is already funding a lot of startup movements. So there is many startups in quantum nowadays. Actually, if you want to start a startup, you will find investors. So there is a lot of money the governments are already investing in, and startups also have money. The other issue which I see happening, and this is a personal opinion, a few years ago, so 30 years ago, before I was born, research started at national labs, and research at national labs is supposed to be done for society and to benefit society. The problem that has happened now is that, like the train for AI, research is now happening at industries who have their own profits in mind, and they are hijacking the thing for society, which was being done. So I think the national labs, so the government should still focus on the national labs doing research, because we are actually here for the people. And that's where I think there should be more investment, so the government labs could do that. And then, yeah, we're happy to partner with industries, but we shouldn't be waiting for industry to develop something and then we use it. I think we should be developing things in the government labs and then becoming an example for research for the future generations. So that's my opinion, though.
Any thoughts on that, Marcus?
Yeah, I absolutely agree with Miriam. Well, first, Phasecraft has benefited a lot from government grants. It's been very successful in raising government grants in the UK, now in the US. So that is an important source of funding for small startups, especially if you don't want to be subject to the expectations of investors that expect to get a certain return in a certain amount of time, which is not sufficient to actually do what has to be done. So that plays an important role, but I absolutely agree with Miriam as well, that perhaps the funding of government labs whose incentives are well aligned with those of the government is an essential area of focus.
Okay. All right, so we're getting close to the end here, so I have one more question. Working in both an industry and government lab tends to be a little bit more mission-oriented, if I may use that terminology. There's a bit of a focus on what you're trying to do there. That can be both exciting and it can be frustrating, because someone's breathing down your neck trying to, okay, how are you going to get this done next? So would each of you comment on how your take on working in a non-academic environment, particularly in the area of quantum information science, kind of the pros and cons that you have experienced or not? Maybe it's just all great and we should all join you. But let's start with Marcus and go down the row.
Well, my personal experience has been great, and I think you should all join Facecraft. But beyond Facecraft and in previous companies that I worked also, I think, again, because the field is nascent and there's still no industry, quantum computing industry per se, there's no product that serious quantum computing companies are claiming to offer at the moment. Serious companies understand that this is the case, and I never felt pressure to deliver something concrete. I think the companies that I've been involved with, the ones where I worked and the ones that we discuss, all understand the challenges, and the focus is on solving the problems that need to be solved for a quantum computer to work, because at the moment we have lots of problems that have to be solved before thinking about a product or anything like this. So my experience has been very positive. I hear some people who've worked in some sectors of the industry maybe haven't had this experience, and this goes back to understanding or being able to identify the serious and the visionary players among all the ones that exist. And that's a place where SIAM can help people figuring that out.
Okay, Miriam, you want to comment with the DOE? Because I know some of the labs are very mission-oriented. Oak Ridge is open science, so you're maybe a little bit less.
Yes, so I've been in the DOE system for about 7 years now. I haven't worked in industry, so I cannot give you that perspective. But even so, building my career through the Department of Energy labs, I think you always have to think about the impact which your work is leading to. So even if you're designing an algorithm, how is this algorithm going to impact the average person on the street? So you should be thinking about how your work is going to be translated to the average person, because that also, it inspires you to do something because you think like you're making a difference, but also, yeah, you also can defend your work when you're actually talking to people like, why am I doing this and why this is important? Because that's what gets you the funding to get the work done also. So I've had good experiences working in the DOE system, and I work with great intelligent people, so I learn a lot from them every day.
Ruslan, can you comment, and particularly management at JP Morgan Chase, are they breathing down your neck? Or?
I think it's great. You should all join JP Morgan Chase. In fact, we have many open positions for you to do so. But I think one thing to say is that this mission-oriented or the being focused is not a bad thing. Like, as a field, we do have this urgent problem now, especially with the new demonstrations, that experimentalists are going to build these devices. They're on track to build these devices. And as an algorithms people, we don't have terribly good answers on what to do with them. Or we don't have answers that very convincingly say, coming back to another question from Kirk, how do we make money with quantum computers? Like, if we don't figure that out, then we're not going to have quantum computers, right? There is a reason. The reason we have these awesome GPUs that are super powerful, you know, you can ask ChatGPT to write a piece of code for you, is, well, it's profitable, right? Like, the flywheel has started, and decades of continuous development enable these better and better technologies. If we don't start this, if we don't come up with something to do with these early fault-tolerant devices, which are coming not too long from now, hundreds of qubits, billions of gates, then we're going to have a problem as a community. So I think the sense of urgency is very, very justified.
Okay, well, we've exceeded our time slightly, but I want to thank the panel for enduring my questions. Hopefully you will have come up with some additional questions to ask either directly or put up on the board. So I will thank the panel. Let's thank the panel.